In the first video of this lesson, we defined a function, we gave the definition, and we said that a function has three parts: an input value, a mathematical rule, and an output value. And we looked at this specific example here, this equation y equals 2x plus 3, and we said that this was a function where if we put in specific input values, such as x equals 4, then we'll get exactly one output value that corresponds with that input value. So in this particular example, to get y equals 11, that output value, would you agree with me, depended on the fact that x was 4, right? So to get an output value of 11, it depended on what we put into the function for the input value. And then we looked at another example where we got an output value of 23. And again, to get an output of 23, it depended on the fact that the input value for the function was 10. Okay, so I'm going to rewrite or just summarize what I just said there. For this particular function, we can see that, or for this particular example, we can see that the output value of the function being y equals 2x plus 3 for this specific example, depended on the input value. I'm going to put quotations around this phrase because it's kind of long, right? The output value of the function y equals 2x plus 3 depends on the input value. So is there another way for me to write that phrase, that long phrase with all those words, but maybe use a shorthand or a notation so it has the same exact meaning? And the answer is yes. So this is where the idea of function notation comes in. Function notation. And I want you to just think about that word notation. Notation just means a shorthand or an abbreviation. So if I want to rewrite this entire phrase using a shorthand or an abbreviation, I can use a notation such as f of x equals y. And hopefully you can see that this notation is much shorter than this entire phrase here, right? But it has the same exact meaning. So f of x equals y is saying that I'm calling this function f of x, and f of x basically means the output value y depends on whatever you put in for x. That's basically what this function notation means, okay? So now, how do we use this function notation? Okay, we just defined this equation y equals 2x plus 3. We just called it f of x, right? So if f of x is equal to y and y equals 2x plus 3, then y is the same thing as f of x, and f of x is the same thing as this equation right here. So how can we use this notation to help us? We can use the notation to write a couple of expressions that, if we wrote it out in words, would be kind of long. So for example, if I wanted to say for the function, here, let me move this up so I can have more space to write. For the function y equals 2x plus 3, when x equals 4, then y equals 11. Is there another way for me to write this expression using fewer words and symbols? And of course the answer is yes. So what I'm going to do is I'm going to use function notation. So since I defined the function y to be f of x, right, I can rewrite this phrase by simply writing f of 4 equals 11. And this notation, f of 4 equals 11, means for the function y equals 2x plus 3, when x is 4, then y is 11. So if I were to write this notation, f of 10 equals 23, then that means when x is 10, y is 23. All right, so that is a much shorter way of writing out the words for the function y equals 2x plus 3, when x equals 4, then y equals 11. Right? We can say the same thing using this simple notation. So a good comparison to help you think about, or a good analogy to think about functional notation, is to think about how you text. So in the texting language, if we want it to, let's say we want it to text, oh, laugh out loud. Well, that already is a lot to text. So instead of texting laugh out loud, is there a notation or a shorthand that you could text that most people would understand the meaning of if they were, texting a lot and they understood the texting language? And the answer is probably yes. If you were to text LOL, most people would understand that that means laugh out loud, just because that's how we define LOL in the world of texting, right? So functional notation is the same idea. Once you define what the notation is, then we can use it to write expressions, but to do it with fewer words, letters, and symbols.